The first on-site innovation that our office would like to present is what we call a folded Austin Vault sand filter. The goal of this stormwater treatment measure is to achieve our water quality obligations per regulatory agencies within a heavily urbanized corridor or heavily urbanized project site. One example of this is the Fifth Avenue project along Interstate 880 in the city of Oakland. The original proposal to satisfy our stormwater treatment obligation was what is called a full sedimentation Austin Vault sand filter. This is a headquarters sanctioned, statewide approved design. However, on this particular project site, there were varying constraints. One being a state right-of-way constraint, one being neighboring land use constraint, i.e. a railroad is in proximity to the site. And the third was also the available space between bent locations along the interstate itself. The innovation is to, as was mentioned before, fold the geometry of the Austin Vault sand filter such that the full benefits of the standard Austin Vault sand filter can be met, but in a much more compact design. Both the exterior and interior geometries were altered, as well as having two nested basins, a sedimentation basin and a filtration basin, which are components of the Austin Vault sand filter. There are many benefits from this folded design, and one is to achieve, of course, we achieved our stormwater treatment goals. That was a plus. The second was that it was an above grade design or above ground design. And the benefits of having an above ground design was such that ease of maintenance access, less concrete quantity would have to be used as opposed to a below ground design. And also it provided flexibility for the outfall of the effluent. For instance, the effluent could flow just overland, or it could attach downstream to a drainage inlet. So it provided more flexibility than a subsurface design. Additionally, because this folded Austin Vault sand filter was sited beneath Interstate 880, we could use the available hydraulic head from the structure itself to help the Austin Vault sand filter function hydraulically.
My name is Wilford Martono. I'm a civil transportation engineer working for Caltrans District 4, Division of Environmental Engineering, Office of Water Quality. Today I'm going to speak with you one of the innovations in our office called hydromodification management storage pipe. Before I talk about the storage pipe, I will try to speak a little bit about the hydromodification management. In hydromodification management, we manage the pre- and post-construction stormwater runoff leaving the project site. As you know, after construction, usually the stormwater runoff will change dramatically from prior to the construction project. In a typical solution to manage hydromodification is the placement of 15 feet wide minimum biofiltration strip or swale. This is a challenge in most Caltrans projects, especially of the right-of-way acquisition needed. As you know, right-of-way acquisition means project cost and schedule. For the storage pipes, we can place them under existing pavement shoulder or pavement structure, thus no right-of-way acquisition, thus no increase in cost, no schedule runoff. There are other two additional benefits to the use of storage pipes. One, it can be easily integrated to proposed drainage system. Second benefit, it's easy to maintain because of the placement of screen. Thank you very much.
My innovation is for the Presidio Parkway project, and it is the LiDAR documentation of historical resources. The Presidio Parkway project is located in the Presidio of San Francisco and the Golden Gate National Recreation Area, one of the nation's largest urban parks. The project lies entirely within the boundaries of the Presidio National Historic Landmark District. Over 70 fragile historic buildings, with many being over 100 years old, are within 200 feet of construction. Caltrans and the project team strives to ensure that each building is protected from inadvertent construction impacts. A sophisticated multi-component program was established to document and monitor the condition of each building before, during, and after construction. The application of LiDAR, which stands for Light Detection and Ranging, which is an optical remote sensing technology, to expediently document pre- and post-construction physical condition of each building with very high resolution, is an essential aspect of this program. The utilization of LiDAR technology allows Caltrans cultural resource managers to successfully and efficiently manage a large number of sensitive historic resources in the midst of a complex and fast-moving design-build construction environment. This approach not only demonstrates Caltrans' respect for the project setting within a national park, but showcases Caltrans' ability to seize this unique opportunity to confidently prove to project stakeholders, partners, landowners, and the public Caltrans' commitment to preserving our nation's heritage. At the end of the project, the successful use and implementation of LiDAR technology to protect and document historical resources has become a tremendous motivation to employ this innovative strategy elsewhere in the district and across the state. It is my hope and our office's hope that in the future this innovation will become a common tool that our practitioners across the state can use on a wide range of projects.
Today I will be discussing the Freeway Performance Initiative projects, otherwise known as the FPI projects. And some of the challenges with these projects were that they ranged from 9 to 26 miles in distance, some of them stretching from county line to county line. And some of the work that was included with these jobs was on-ramp widenings, traffic operations system elements, and things like changeable message signs were included in these projects. Some of the challenges that were involved with this project had to do with the schedule being very tight. We also had issues with project footprints where we needed to know ground disturbance for activities like trenching and the construction of retaining walls. But one of the other problems with this is that our design squad normally doesn't come up with this information until 65% PS&E. Conventionally, environmental usually clears this stuff by looking at a strip of land on either side of the road. And then one of the other final constraint was environmental just didn't have the time in the schedule or the resources to conduct the process that we normally do to provide environmental clearance. So some of the innovations that we incorporated into this project to meet those constraints were the increased coordination with all the project design team. Instead of just having general PDT meetings, we had a lot of focus meetings with the specialists and the functional units involved. And we also had lots of field meetings. The field meetings were very crucial in the beginning for scoping reasons and getting the scope narrowed down for us to provide the environmental clearance in the amount of time allotted to us. And this also included bringing in specialists and functional units that were required to determine the scope of the project and also the constraints that were involved with the project. One of the other resources that we incorporated was a lot of desktop research, and for environmental that included creating maps that showed areas where we had known resources, for instance biological resources like endangered species, or cultural resources where we know that there were buried artifacts and such. And then the other thing too was just distinguishing the difference between want and need for this project. Traffic needs aren't always the same at every intersection, so whenever we had an issue with a certain intersection or area, we would look at the actual traffic volume for an intersection, for instance, and if the traffic volume didn't warrant it, then we could drop elements at this intersection. For instance, if there was a biological resource nearby, we would eliminate the widening if there wasn't enough traffic volume to allow for the widening or for us to have to widen. And basically, to meet these goals, we worked in conjunction together, and we had lots of meetings, and basically were able to achieve the goal by lots of coordinated meetings and lots of communication. These freeware performance initiative projects will increase and improve traffic flow throughout California and especially the Bay Area. Thank you.
My branch is the Erosion Sediment Control and Mitigation branch, and we deal primarily with erosion and sediment control, but we also deal with projects having to do with environmental mitigation for the 401 certifications related to the Regional Water Quality Control Board. In other words, environmental mitigation. The two projects that I'd like to talk about very briefly has to do with one project in Doyle Drive, San Francisco, and another project up in Geyserville in Sonoma County. The Doyle Drive project entailed putting forward a propagation and collection and salvaging contract of native plant materials. The reason why we did this is that when you're working in a national park, that there are strict rules to reuse native plant material from within the park. And given that we were doing the Doyle Drive project, there was a great need to try to accomplish this collection before the road work started so that there would be no delays. This is a very innovative strategy because generally clearing is involved with the roadway project itself. By doing this early project, it afforded us to be able to take care of all these needs outside of the nesting season, but also we found that we were provided the flexibility to deal with problems that arose, such as we found a manzanita bush that was thought to be extinct, and we were able to salvage and relocate it successfully without delay to the roadwork project. We believe that these advanced projects to do this kind of work serves as a blueprint for other projects in the future. The second project I'd like to talk about is the Geyserville Bridge Stabilization Project. This is a project where there was erosion and scouring occurring at the west end of the Geyserville Bridge. What was innovative about the work here is the normal way or traditional way of engineering for this kind of fix is to place rock slope protection. However, in this case, the permitting agencies wanted a solution that was more environmentally compatible. Thus, we came up with a biotechnical design which incorporated general engineering concepts, but also concepts utilizing rock to deflect flows rather than to abate scour, and also to incorporate plant materials like willows and logs to provide the habitat. This project has worked very, very well, and the permitting agencies have come back to Caltrans and suggested that we use this as kind of a guide to when working in riverine areas. And again, the innovative part was to use engineering concepts in a fashion where it is compatible with the surrounding environmental surroundings. Thank you very much.